See this problem. A straight horizontal conducting rod of length 0.45 meter and mass 60 grams is suspended by two vertical wires at its ends. A current of 5.0 amperes is set up in the rod through the wires. What magnetic field should be set up normal to the conductor in order that the tension in the wires is 0? This is our first problem. What will be the total tension in the wires if the direction of current is reversed, keeping the magnetic field same as before? Consider G is equal to 9.8 meter per second square. This is our second problem. Now come to our motive. There is a rod which is hanged at its ends using two wires. So the weight of the rod acting downwards as mg. So this weight will be supported by the wires in terms of tensional force. A current is flowing inside the rod. A magnetic field is set up normal to this flow of the current such that the tensional force in these wires should become 0. So I am keeping this N and S. So the magnetic field here is in this direction. Your current direction is in this direction. So according to Fleming's left hand rule, if you consider your left hand's thumb, forefinger and middle finger, and if you stretch in such a way that all three are mutually perpendicular to each other, then your forefinger will show the direction of the magnetic field and your middle finger will show the current direction. Then your thumb will show the direction of the force applied on the current carrying conductor. In this case it is upwards. So when it is applied towards upwards, the tension in the threads will become 0, because instead of hanging, some force is letting that rod to lift up. So then your tension will become 0 here. So we need to find out this magnetic field. That is our first question. If you reverse the direction of the current, what will happen to the tension? That we need to find out. These two are the things we need to find out. That is our motive. Now come to investigation part. The length of the rod L is given, that is 0.45 meters, and mass of the rod M is equal to 60 grams, and current flowing in that rod is given, that is 5 amperes, and G is equal to 9.8 meter per second square. Now I am going to resolve the problem. Here the magnetic field applying some force, magnetic force on the current carrying conductor, and that force can be written as FB is equal to BIL. And due to gravitation, the rod is pulled downwards, and that gravitational force Fg is equal to M into Z. These two are balanced so that the tension will become 0. So then BIL is equal to Mg. B is equal to Mg by IL. So I am substituting the values. B is equal to 60 into 10 to the power of minus 3 kg into 9.8 meter per second square divided by 5 amperes into length is 0.45 meters. That is equal to 3 4s are 3 0.15s are. So if you write 4 into 9.8 divided by 0.15 into 10 to the power of minus 3 Tesla, which can be simplified as 0.26 Tesla. So we got one value. And in second case, if we reverse the direction, it will be pushed downwards. So at that moment, along with the gravitational force and this extra force coming from the magnet, that will also help to pull down. Force on the conductor will become more. That will be doubled. At first those two are same and now they are acting in one direction, so your force will become double. So it will be experienced by 2Fg, that is 2 into mg, that is equal to 2 into 60 into 10 to the power of minus 3 into 9.8, that is equal to 1.18 Newton.